recap about this. Okay, in extraction of aluminium, the ore was bauxite, and purification was done because you first had to purify this aluminium ore, because it contained impurities. It had other metal oxides that were also present in it. So the first thing that was done was that these impurities, iron oxides, etc., these were removed. Aluminium oxide is the main ore. We need to extract that. Those kind of impurities are supposed to be removed. And the way that's done is metal oxide, that's basic. Aluminium oxide is a special kind of metal oxide, which is amphoteric. So it can react with both acids and bases. So you dissolve it in concentrated NaOH. Aluminium oxide reacts because it's capable of doing both, reacting with alkalis as well as acids. Metal oxides are basic. They don't react with other bases. So they don't dissolve. And so iron oxide does not dissolve, and it is then filtered off. And you filter it off and you're left with aluminium oxide. It's going to react with NaOH. It's going to dissolve in the solution, and it's going to form a salt and water molecule. The process how this salt is converted back into aluminium oxide is not very important. Okay, so we can ignore that. We just need to know, okay, how is iron oxide and other metal oxides removed from the ore. That's the first step up here. When you have pure alumina, it is then electrolyzed. Okay, so I gave you a brief overview of what electrolysis is. It's the decomposition of a substance by passing current through it. So this was the process. There was a graphite. And we did not complete this actually. So aluminium oxide was molten. It had aluminium ions and it had oxide ions, O2 minus ions. They were present in the mixture. In molten state, the ions can move around. The temperature was 950 degrees centigrade. So all the aluminium ions and oxide ions, they can sort of move around, and they can freely move around because they have a lot of energy. They can overcome the attractive forces. Liquid state mein yahi hota hai. So one of the terminals, this comb-like structure, was connected to the battery's positive terminal. Positive terminal attracts negative ions. So all the negative ions are going to get attracted. They're going to be, because positive attracts negative. So all the negative ions, they're going to go and stick to this comb-like structure. And all the positive ions, the aluminium ions, this container is also graphite lined. It's a conducting material, and it's connected to the negative terminal of the battery. So negative attracts all the positive ions. So all the positive ions, they get attracted to the container. So in a way, the ions separate in the mixture. One gets pulled to one side, and the other ones, they get pulled to the other side. Phir wahan jaake what happens when they go there? Aluminium ions, the purpose of the negative terminal of the battery is that it's sending electrons. It's sending loads of electrons to this container. Somebody over here has to gain those electrons because there are lots of electrons coming from the battery. Aluminium is positively charged. So by default, a positive ion is going to attract negative electrons. So aluminium ions, they start attracting the electrons because they're getting, the battery is sending them electrons. A lot of electrons are coming their way. So aluminium ions end up gaining 3 electrons to form aluminium metal back again. And that results in the formation of molten aluminium metal, so the bottom of the container is now, this blue line over here, that's molten aluminium that's being formed at the bottom of the container. ठीक है, यहाँ तक ये बस quick revision करें. ये सारा clear है? Anna, is this clear?
Yes.
अच्छा. On the other side, you had O2 minus ions. O2 minus ions, they were attracted to the positive terminal. What was the purpose of the positive terminal of the battery? Uska role hota hai कि it pulls the electrons. ठीक है, it's trying to gain electrons. So where would it gain those electrons from? The only ion that's present over here is O minus 2 ion. So all these oxide ions, they end up losing electrons to form neutral oxygen molecules. ठीक है, O minus 2 loses electrons. It was supposed to lose 2 electrons, but since oxygen never exists as a single atom, so you have two oxide ions losing a total of 4 electrons to form two oxygen atoms that are going to get together to form an oxygen molecule. So इस side पे oxygen molecule is being produced, and on the other side there's aluminium that's being produced. ठीक है, so we are interested in this aluminium. And some other things that I mentioned were that cryolite is added in the mixture. As a cryolite has only one purpose, that it's mixed with aluminium oxide. Aluminium oxide, to decrease its melting point, it's kind of an impurity. If you mix it with aluminium oxide, the melting point of aluminium oxide is extremely high. Cryolite brings it down. It makes it easier to melt. Because if this mixture is not molten, the ions would not be able to move on their own. So it has to be molten, because solid state mein the ions are stuck. They can't move around. So you need a molten state. So it makes it easier to melt. So electrolysis is possible, and it reduces energy cost, because if it's easier to melt, so easier to melt, the temperature that is required would be a lot easier to. 950 degrees centigrade is not a very, very high temperature. So you don't have to burn a lot of fuel to heat this aluminium oxide. So your energy cost is going to be reduced. Okay, so it's going to make it more economical. I said this is what we did yesterday. Okay, Mahad, clear? Any questions about this?
No, sir.
Acha, now we left halfway. Okay, we did miss a few things. One very important thing that's very frequently asked. That is, if you look at this anode, the positive electrode, okay, this positive electrode is known as anode, the positive terminal that's connected to the battery. What is it made out of? It's made out of carbon. And what's forming on the anode is oxygen. So there's oxygen gas being formed, and this entire comb-like structure, it's made out of carbon. So there's going to be a reaction over here. A reaction would happen that the carbon electrode or graphite electrode, it catches fire because the temperature is very high as well. So the carbon or graphite electrode catches fire, and starts to burn in oxygen. So carbon and oxygen, they're going to react to produce carbon dioxide. Okay, so this happens, and the electrode, this comb-like structure on the top, it has to be constantly replaced. क्योंकि उसके ऊपर oxygen gas produce हो रही है, and the oxygen gas, it starts reacting with the comb-like structure क्योंकि it's made out of carbon. So the carbon starts to burn. So anode has to be replaced at regular intervals. क्योंकि it gets used up, it forms carbon dioxide, and it has to be replaced at regular intervals. ठीक है, is this clear? साथ ये बात clear है?
Yes, sir.
ठीक है, ये भी important है. ठीक है, this is very frequently asked. Write the reactions that are happening at anode. So one of them is this, the formation of oxygen, but this is also a reaction that's happening at the anode के वो खुद ही burn करने लग जाता है oxygen के साथ. अच्छा, फिर last time there was a question about Na3AlF6. ठीक है, there was a question about this. Why is this? The question was, if you add cryolite, isn't it an impurity, and wouldn't it sort of mix with the substance and make the aluminium impure? Na3AlF6 has two things. Okay, it has Na+1 ions, it has aluminium ions, and it has fluorine ions. Okay, they combine to form Na3AlF6. So two of them are positive ions, one of them is negative ions. So another thing that might be produced, not always, but to a very, because you're not adding, first thing, remember, you're not adding a lot of cryolite. Cryolite का सिर्फ एक छोटा सा purpose था कि it was reducing the melting point. तो इसको हम ऑरेंज में लिख लेते, किस कलर में लिखें, ग्रीन में कर लेते हैं, ठीक है. अच्छा, so if F-1 ion is present in the mixture, so there are chances, there won't be a lot of F-1 ions, very few F-1 ions. Remember, we're not adding a lot of cryolite. ठीक है. Mahad, this was, I think, your question. So ये अभी तक clear है कि the F-1 would also be attracted to the positive electrode. Is that clear?
Yes.
So another reaction might happen, which is at anode. And that reaction would be that F-1, as an anode pe ho kya raha hai? The battery is pulling electrons or removing electrons. It's trying to extract electrons. So if F-1 goes over there, so F-1 would also end up losing electrons. So -1 means it has one extra electron. So it ends up losing an electron to form fluorine. But remember, group 7 is also diatomic. A single fluorine atom will not exist. It's always F2. So you need to make two fluorine atoms. So there would be two F-1 ions. They would collectively lose two electrons to form two fluorine atoms, which would combine together to form an F2 molecule. So this reaction, to a very limited extent, can happen. But it wouldn't affect the aluminium at the bottom. You're getting the aluminium at the bottom. So we're not really concerned with the anode. So where are you getting? I'm just going to write this down. Some F-1 ions from cryolite would also be oxidized because they're losing electrons. Loss of electrons ko kehte the oxidation. So they would also be oxidized. So this is also one of the reactions that might happen at anode. ठीक है, Mahad, is this clear?
Yes.
अच्छा, अब फिर मसला है कि so we're done with F-1. F-1 is not an issue. It's not going to really affect our aluminium. अच्छा, what about Na+1? अब Na+1 का issue हो सकता है कि if you add a bit of cryolite in the mixture, so Na+1 will get attracted to the negative terminal. ठीक है, जो container है, that's connected to the negative terminal. So the positive ion might get attracted to the negative terminal, but there wouldn't be a lot of cryolite, so very few Na+1 ions. As Na+1 ions, the reason they are not going to cause any problem is कि इसके नीचे लिख देते हैं. The reason they're not going to cause any problem is कि Na+1, पहले तो वो लिख देते हैं कि ions, they do get attracted. One second. So they do get attracted to cathode. But the thing with sodium is that sodium is very reactive. So Na is a very reactive metal. So it always likes to lose electrons. It doesn't like to really gain electrons. So it would not gain electrons. It would not like to gain electrons. So there wouldn't be any reaction at cathode. ठीक है, ये idea clear है कि Na+1 will come over here, will get positive ion, will get attracted to the negative cathode, But Na+1 is so reactive that it always has a very strong tendency to lose electrons and form positive ions instead of doing the opposite. ठीक है, so if there's Na+1 formed, so it really doesn't like to gain those electrons back. ठीक है, ये metals की reactivity में यही था ना कि जब हमने metals की reactivity पढ़ी थी, the more reactive the metal, the more stronger is its tendency to lose electrons. So it's not really going to try and gain electrons back. So it's not going to do anything over here. ठीक है, it's not going to form sodium metal. So it's just going to end up roaming in the solution. Aluminium ions would be the ones that would be gaining electrons that are coming from the negative terminal of the battery. So ये थोड़ा बहुत clear है? Siddha, is this clear? Anna? बाकी भी?
Yes. Yes.
ठीक है. Is it the idea clear है?
Yes, sir.
अच्छा, so अच्छा, लेकिन ये वाला जो है ना, this questions on this would be kind of very rare. लेकिन ये हम आगे electrolysis के अंदर ना detail में cover भी करेंगे, so don't worry about that. अभी तो main reactions के extraction of aluminium. Just remember, you had two ions, aluminium and oxide ions. Aluminium went over here at the negative terminal, gained electrons and formed aluminium metal. And you had O-2 ions over there, and they lost electrons to form oxygen gas. और फिर वो था कि oxygen gas, it ends up reacting with वो जिस चीज से वो बना हुआ है, ये जो comb-like structure है, carbon से, ends up reacting with it and ends up forming carbon dioxide. So वो comb-like structure now has to be replaced at regular intervals. One reaction that might happen is that F-1 ions from cryolite might also be losing electrons at anode. So they might also get oxidized. It won't be a very huge reaction because cryolite is in small amount, but fluorine gas might be produced. ठीक है, और cryolite में जो Na+1 है, that would get attracted to cathode, but it's not going to do anything at the cathode. Because it doesn't really have a very strong tendency to actually gain electrons. Because Na is very, very reactive. Lose करता है, gain बड़ी मुश्किल से करता है. So this is the entire process of extraction of aluminium. इसमें, I remember I've written down all the steps, all the essential requirements जो syllabus की requirements हैं. ठीक है, book में lots of other things would be written, but this is all that you need to really know to answer any question on extraction of aluminium. फिर आगे थोड़ा सा ना aluminium के uses we can discuss. जैसे हमने iron का steel का पढ़ा था, so let's discuss what is aluminium used for. So uses of aluminium. Achha, aluminium, you must have seen metal doors and windows made out of aluminium these days. One of the reasons why aluminium is kind of more expensive than iron is, एक मैंने पहले बात की थी कि aluminium is actually more abundant than iron in the Earth's crust. Aluminium is easier to extract. There's more ore of aluminium. बस aluminium का मसला ये होता है कि the process is kind of more complicated compared to iron, which is why it's kind of more expensive. तो वो अपने process की वजह से ना it's more expensive. There was actually a time when aluminium was क्योंकि electricity नहीं होती थी ना, ये तो अभी electricity आ गई ना, electrolysis. Around 100, 200, 300 years back, it was because you didn't have any electricity, you didn't have a method to produce electricity in huge amounts. So it was actually, during that time, aluminium used to be very expensive. Even gold, Sivina, it was more expensive than gold. But then they discovered electricity and especially mass level cube, how to produce electricity in a huge quantity. So then they were able to, electricity cost come with it, and they were able to extract aluminium in a lot cheaper way. वो जो दूसरा काम है ना आयरन की एक्सट्रैक्शन जो हमने पहले की थी वो बड़ा सस्ता काम है उसको मतलब you just take coke and you start burning it, that's it. मतलब mainly तो आप वही कर रहे हो ना. और वो जो impurities remove करने के लिए limestone डालते हो, limestone is basically chalk, ठीक है, marble और chalk. So that's kind of cheap as well. So iron के जो raw materials है ना extraction के, they're kind of very cheap. which is why overall iron is a lot cheaper and easier to make rather than aluminium. ठीक है, which is why aluminium has a higher cost. अच्छा, हम उस पे थे uses of aluminium के ऊपर. Now, uses of aluminium. Aluminium has extremely it has really good properties. Two of them are very good properties. One of them is that it's low density, very light. Okay, if you have seen an aluminium door, it feels light. It's kind of ये aluminium के अब ये बन रहे हैं. Phone cases are made out of aluminium. Your laptop cases are sometimes made out of aluminium. Cars are now even made out of aluminium. Okay, because it's getting cheaper and cheaper to make. So car bodies, phone, laptop covers, windows. So it's a very useful metal. Okay, and it's becoming more and more popular. Iron कम ही use करते हैं लोग आजकल. पहले तो iron ही use होता था mostly, but now they've most of the people have switched to aluminium. As a low density, lightweight, so it's kind of good. The other one is doesn't rust or corrode. So it's naturally rust proof. Iron का मसला it starts to rust. Even जो expensive bikes है ना, ये normal cycles, bicycles, the lightweight ones are made out of aluminium. ठीक है, the heavier ones, the cheaper ones are made out of iron. Iron भी नहीं बल्कि steel. ठीक है, तो अच्छा, so aluminium doesn't rust or corrode. उसकी रीजन हम डिस्कस कर चुके हैं वो वाटर के साथ रिएक्शन के अंदर कि व्हाट वाज द रीजन व्हाई एल्युमिनियम डजंट रस्ट. कि if you have a piece of aluminium, what happens is, just one second, let this appear. एक सेकंड, बोर्ड नहीं लोड हो रहा. ठीक है, अच्छा, so if you have a piece of aluminium is going to react with, let's say there's moisture and there is oxygen in the air. So aluminium would react. It's not that it doesn't react with. It's a reactive metal. Reactivity series में ना, it's actually even मतलब the reactivity series. If you have a look at the, मतलब यहाँ ऊपर जाना पड़ेगा. अच्छा, if you have a look at the reactivity series, you would notice that aluminium is kind of even more reactive than iron. Iron थोड़ा नीचे आता है. Aluminium is मतलब ऊपर से 5th number पे. So it's one of the reactive metals. So तो चीजें इससे नहीं बनानी चाहिए थी क्योंकि ये तो हर चीज के साथ रिएक्ट कर रहा होता. But apparently it doesn't react, doesn't rust, doesn't corrode. Why doesn't it not do that? कि वो react करता है. ठीक है, it quickly starts reacting, immediately starts forming oxides. Water के साथ react करेगा, it would do pretty much the same thing. It's going to form O2 भी डाल दो, so it would form aluminium hydroxides and oxides. So these reactions are going to happen. But the thing is as soon as these reactions happen, इसकी जो top surface है ना, इसके ऊपर ये oxide की layer form हो जाती है, which is Al2O3 immediately. And this coating of Al2O3, it's a very tough coating. It forms this protective coating around aluminium. So it's tough, it's unreactive, and it's non-porous. Non-porous का मतलब है nothing can actually get to this piece of aluminium that's inside, but it gets completely surrounded by this coating. So the coating of Al2O3 is tough, it's unreactive, it's non-porous, and stops any further reaction. So naturally, it stops any further reaction of aluminium metal. तो all the reactions they immediately stop क्योंकि कोई चीज एल्यूमिनियम तक पहुंच नहीं सकती. ठीक है, ये मेरे ख्याल से हमने पहले भी डिस्कस किया था. Is this clear? ठीक है, ये everyone, Ahmed clear है? Sidra, is this clear?
Yes.
Yes.
So now based on this, there's several uses of aluminium. अच्छा, एक तीसरा तो डिस्कस ही नहीं किया. दो तो हो गए, low density, doesn't rust. Third one is it's an excellent conductor of electricity. It's one of the metals that is one of the best conductors of electricity. So very good conductor of both things, heat and electricity. Oven वगैरह के अंदर भी ना even your pans are made out of aluminium. वो जो aluminium foils होती हैं, ठीक है, why do you do that? Because they're very good conductors of electricity, of heat and electricity both. As a reason they're very good conductors of electricity is that aluminium loses 3 electrons. But it's in group 3, it loses 3 electrons. Hence, it has more delocalized electrons. So it has lots and lots of delocalized electrons. And उसका जो structure होगा ना aluminium का, वही structure होगा metal वाला, positive ions in a sea of free moving electrons. But the only issue is कि because aluminium is losing so many outer shell electrons, there would be lots and lots of electrons, and those electrons are free to move any way they like. So they would help electricity conduction. Charges can move around, and heat would be conducted very fast as well. Okay, if this electron over here gains energy, it quickly jumps to the other side and transmits energy to something else. So the flow of heat is going to be very, very fast as well. Okay. Is this clear? Mahad, is it clear?
Yes, sir.
Yes, sir.
So 3 properties. ये याद रखें, uses of aluminium के ऊपर you get काफी questions आते हैं इस पे. Low density, doesn't rust or corrode, and good conductors of electricity and heat. तो उनके वो uses लिख लेते हैं कि number 1 रेड में लिख लेते हैं इस साइड पे. एयरप्लेन्स, ठीक है, ये दोनों उस पे अप्लाई होते हैं कि लो डेंसिटी मतलब airplanes have to be lightweight. So airplanes are made out of aluminium. So that's one major use. इस साइड पे आ जाते हैं because अच्छा airplanes और बाकी अब तो हर जगह यूज हो रहा है, कार बॉडीज and especially expensive cars, they're mostly made out of aluminium. Cheaper cars जो होती हैं, they're made out of steel. So the expensive cars जो होते हैं ना, they also lightweight, low density, so they accelerate more, and they also don't rust or corrode. Even I think they're not painted. ठीक है, ये Teslas वगैरह, you don't even need paint because aluminium is kind of shiny and looks good on its own as well. अच्छा खैर, ये airplanes, car bodies, lightweight bicycles, लेकिन मेन एयरप्लेन्स पे फोकस करो, ठीक है. On the other side, they're very good conductors of heat and electricity. तो हीट के लिए तो वो हो गया ना कि कुकिंग के अंदर कि एल्यूमिनियम क्या कहेंगे उसे कि यूटेंसिल्स एंड aluminium foil, baking वगैरह के अंदर you always anything roasting etc. you're using aluminium foils. फिर high power transmission, उनकी जो cables होती हैं, especially the overhead cables, खास तौर पे if you have seen the big pylons of that are carrying high voltage power lines होती हैं कहीं पे, must have seen them on highways. So they are all वो silverish सी होती हैं, they're always made out of aluminium. घरों के अंदर copper is used, ठीक है, copper is kind of cheaper compared to aluminium. लेकिन जो high power transmission है ना, that is done by aluminium. It's a very good conductor of electricity. So that pretty much sums up aluminium. So we're done with all three things. Extraction हमने सारी कर ली है. If we go back and have a look, कहाँ से start किया था? यहाँ पे. अच्छा, we've done ये जो तीन green के अंदर circle हुए हैं ना, we're done with that. ठीक है, extraction of aluminium, extraction of iron, and extraction of zinc. So all three are done. तो अब हम ये करेंगे कि we are going to try and do some past papers. कोई questions तो नहीं है इसके बारे में? Is there any questions? Anna, any questions?
No.
अच्छा, उस पे अब चलते हैं कि past papers खोल लेते हैं. Just one second. और ये इस पे हम बार बार आके ना just one second. As I'm just going to focus on extraction of metals right now. एक second, let me. अच्छा, इसके हम कर रहे थे papers हम कर रहे थे. Hopefully you can, हाँ ठीक है, you can see the screen. तो ये वाला तुमने किया था, एल्यूमिनियम वाले कोई क्वेश्चंस करते हैं. हाँ ये है वह. अच्छा, फर्स्ट थिंग स्टार्ट से कर लेते हैं, ठीक है, फ्रॉम स्क्रैच. द फर्स्ट थिंग इज यू बीइंग आस्क्ड, ठीक है, क्वेश्चन नंबर 4. आई एम गोइंग टू सेंड दिस वर्कशीट एज वेल. Question number 4 is write an analytic equation for the reduction of, ये मैंने बार बार word use किया, reduction. I told you कि there's a thing called oil rig. इससे बस याद कर लो. Oxidation is loss of electrons, reduction is gain of electrons. So this is gain of electrons. Acha, he's saying कि write the equation for aluminium ions changing into aluminium atoms. So aluminium is +3, changing into aluminium atom. So for that, it has to gain 3 electrons. So that is your equation for reduction of aluminium. अच्छा, उसके बाद the question is, the original method of extracting aluminium involved the reduction of aluminium chloride using the reactive metal sodium. Aluminium obtained by this method was very expensive due to, you explained bhi maine kiya tha कि it's very expensive due to the high cost of extracting sodium from sodium chloride. Complete the equation for this reaction. अच्छा, ये जो equation है, if you look at this, और साथ ही if I open this, ठीक है, if you look over here, sodium is over here, right at the top of the reactivity series. This is where sodium is. ठीक है, you can see sodium over here, right at the top. Now sodium is more reactive. So what did I tell you about this? कि a more reactive metal displaces a less reactive metal. So sodium जो है, that's more reactive. लिख देते हैं more. एक सेकंड इसको. अच्छा, so sodium is more reactive. So it's going to what would it do? कि वो aluminium को side पे करेगा, it's going to knock out aluminium and Cl को अपने साथ attach कर लेगा. So it's going to form NaCl. मतलब you know कि Na and Cl they form the formula of Na plus 1 and Cl minus 1. ठीक है, so this is the formula. You need to balance this equation. So there are 3 Cls. So they're going to be 3 NaCls. So जिसकी वजह से there would be 3 sodiums. So they're going to be 3 sodiums on the other side as well. Then he's saying, how can sodium metal be obtained? He's talking about, we did not discuss the extraction of sodium metal. मतलब हमने detail में नहीं discuss किया. Now the question only states, how can sodium metal be obtained from sodium chloride? So what's the process? If you go back and have a look at the notes, तो इसको हम study कर लेते हैं. I said कि carbon से नीचे नीचे जो metals हैं ना, they are obtained by reduction with carbon. कि carbon is more reactive, तो वो जाएगा उसके oxidants वगैरह छीन लेगा and the metal is eventually going to be, it's going to be displaced. ठीक है. ये जो sodium metal है, ये जो top वाले metals हैं, इनके लिए मैंने क्या कहा था, ये जो circle किया हुआ है, I said कि you can't reduce these metals with carbon. So if you can't really reduce them with carbon, what do? You need to लिखा हुआ है, electrolysis of molten electrolyte is used. Electrolyte वो substance है जिसको आप electrolysis करते हो. ये हमने इससे ज़्यादा discuss नहीं किया था, this entire thing. तो हमने सिर्फ aluminium oxide के लिए discuss किया in detail. तो we going to write the same thing कि carbon से ऊपर जो है ना, electrolysis is done. So that is what our answer should contain. कि electrolysis of molten electrolyte, of molten sodium chloride, molten NaCl. ठीक है, you do that and you're going to get sodium. ये clear है? Is this clear? Anna clear है? Saad?
Yes.
Yes, sir.
ठीक है, मतलब ये वो उसमें आएगा same as aluminium oxide. ठीक है, मतलब टोटल आपके पास 2 प्रोसेसेस हैं, एक वो कार्बन से नीचे वालों के लिए और एक कार्बन से ऊपर वालों के लिए reactivity C's में. The next one is, okay, now I think it's वो कह रहे हैं the major ore of aluminium is impure aluminium oxide. What is the name of this ore? ये पूरे process के ऊपर है, ये वो diagram है. ठीक है, I drew it, but almost a similar diagram. अच्छा, what is the name of this ore? So it was bauxite, जिसके अंदर impure aluminium oxide था. Impurity भी discuss की थी. What was the impurity? I think he has already mentioned that below. कि उसने कहा है कि the ore is a mixture of aluminum oxide which is amphoteric. He's already told you कि it's amphoteric. It can react with both acids and bases at the same time. And the other one is iron 3 oxide, which is, so it's basically Al2O3 mixed with Fe2O3. तो ये step 1 की बात कर रहा है कि explain how these two oxides can be separated by the addition of sodium hydroxide. तो सब कुछ ही बता दिया उसने. तो आप ये कहोगे कि amphoteric aluminum oxide amphoteric aluminum oxide dissolves while basic Fe2O3 doesn't dissolve. It doesn't dissolve in NaOH and is simply filtered off. उसकी इक्वेशन भी लिखी थी हमने, although it's not required, 2 marks probably हो चुके हैं. The equation was कि NaOH के साथ if you react it, it's going to form NaAlO2 plus H2O. ठीक है, you can balance this out to और पता नहीं H कितने हो गए. ठीक है, that's fine. ये तो लिखा हुआ भी है कि कहाँ पे एल्यूमिनियम कहाँ पे गया है? जिंक, हाँ यहाँ पे जो स्टेप नंबर 1 है वो यही था, इसी का इशू था, ठीक है. So that is described over here. Then the next one, next page पे. अच्छा, give 2 reasons why the electrolyte contains cryolite. So remember cryolite के ऊपर question आएगा. So why was cryolite added to decrease melting point of alumina? वो जो pure alumina is the pure Al2O3 जिसका आप electrolysis कर रहे हो. Why do you want to decrease the melting point? For 2 things. So that ions can move freely and conduct electricity. The negative ions go to anode and the positive ions they get attracted, so they can move around. So they move freely and conduct electricity. And the other one is it also reduces energy cost, makes the whole process economical. ठीक है, ये सारा हमने क्रायोलाइट के लिए डिस्कस किया था. अब फिर अगला क्वेश्चन है कि the mixture of gases evolved at the positive electrode. सबसे पहले oxygen gas. उसने क्या explain the presence of these gases in the gaseous mixture formed at the positive electrode include at least one equation. So where did oxygen come from? So have a look at the diagram जो से नीचे था. उसमें आप बताओगे कि जी O-2 ions जो alumina के अंदर था, they get attracted to the positive and then write this equation. That's it. So we'll just do that कि O-2 ions उसकी पहले equation लिख लेते हैं and they're forming O2. So oxide ions in pure alumina get attracted. So they get attracted to, where do they get attracted to? The positive anode, where they are oxidized. चलिए अब टाइम कम है, ये where they are oxidized. फ्लोरीन का भी मैंने कहा था. कार्बन डाइऑक्साइड कब प्रोड्यूस हो रही थी? कार्बन डाइऑक्साइड प्रोड्यूस हो रही थी कि इफ यू लुक ओवर हियर, ऑक्सीजन गैस वो इधर प्रोड्यूस हो रही थी कि ऑक्सीजन गैस जो है वो कार्बन के साथ रिएक्ट करना शुरू हो गई थी क्योंकि इट्स मेड आउट ऑफ कार्बन एंड इट वाज फॉर्मिंग कार्बन डाइऑक्साइड. अच्छा, इधर मैं ऐड कर देता हूँ कि अगर इनकम्प्लीट कंबशन होगी तो कार्बन मोनोऑक्साइड कैन आल्सो बी प्रोड्यूस्ड. तो इसलिए वो they've given carbon dioxide and carbon monoxide both. Fluorine came from cryolite. तो उन सारों की explanation, it's a 5-mark question. ये हम फिर कल complete करते हैं. Any questions about this? अहमद कोई question तो नहीं है? ये मैं
No.
बाकी सारे महाद, is this clear?
Yes.
ठीक है. तो Aisha, is this clear? चलिए करते हैं कंटिन्यू. I'll बस ये आज मैं कोशिश करता हूँ I'll send you this worksheet as well so we can solve this together. ठीक है. चलिए we done with काफी चीजें हमने कर ली हैं metals की. ये बस याद करना है. Just go through them. Just make very nice notes, very good notes. क्योंकि ज़्यादातर memorization वाला part है ये. ठीक है. So extraction of metals जो है ना, just make very good notes और उनको neatly ना अपने पास रख लो and keep on revising them. What are the steps? क्योंकि स्ट्रेट फॉरवर्ड क्वेश्चंस आएंगे. तो चलिए ठीक है. तो नेक्स्ट क्लास पे करते हैं बाद में. और ये ओके देन, टेक केयर, अल्लाह हाफिज.
Allah Hafiz.